Hi guys, here is our daily math problem for today. This is taken from the 1999 American High School Math Examination, and here's the problem. What is the sum of the digits of the decimal form of the product 2 raised to 1999 times 5 raised to 2001? And the options are A, 2, B, 4, C, 5, D, 7, and E, 10. You can pause the video and solve this problem first. Now, let's solve this problem together. What we want to find here is the sum of the digits of the decimal form. What do we mean by decimal form? If we want to get the decimal form of this, we are going to evaluate the exponent. For example, if you have 2 squared is the exponent form. The value of 2 squared is equal to 4, and this 4 is the decimal form of 2 squared. So that means in here we are going to get first the decimal form of the first factor 2 raised to 1999 and the second factor 5 raised to 2001. But if you try using your calculator to evaluate 2 raised to 1999, you'll find out that there are so many digits in the decimal form. In fact, there are thousands of digits. So because there are thousands of digits in the decimal form of this product, using calculator or computer would be not our option to solve this problem. So what are we going to do? We are going to use our laws of exponent. But first, notice that there could be 2 approaches that we can use to solve this problem. Either we can convert this so that they have the same bases, or we can transform this so that they have the same exponents. Now, coming up with the same base would be difficult, but there's a way for us to come up with the same exponent. So let's recall the product rule of exponent. The product of a to the m times a to the n is equal to the common base raised to the sum of the exponents. Now, using this rule, notice that we can split the exponent into m plus n, and the product would be a raised to m times a raised to n. That is what we can do here. We can split 2001 into 1999 plus 2, so that we can now have this form, although we are going to use the converse of this rule later on. Then we just copy the first factor. Using now the converse of this rule, this part here at the right would be equal to the base a. In this case, the base is 5 raised to the first addend times the same base raised to the second addend. That is exactly the application of the converse of this product rule. We just copy the first factor here. Now we have 2 raised to 1999 times 5 raised to 1999. So we now have the same exponent. So let's recall the power of product rule of exponent. So when we have the product a times b raised to m, that is equal to the first factor raised to m times the second factor raised to the same exponent. And using the converse of this, we can now rewrite these first 2 factors as the product of the bases 2 times 5, that is our a times b, and the exponent would be the common exponent 1999, which is our m. And we just copy 5 squared. Now we can multiply the base 2 times 5, that is equal to 10, and copy the exponent 1999 and copy 5 squared. Now 5 squared is easier to write in its decimal form, that is 5 times 5 equals 25. What about 10 raised to 1999? Now let's observe the pattern. If we have 10 raised to the first, that is equal to 10, 10 squared is equal to 100, 10 cubed is equal to 1000. What do we notice? If the exponent is 1, there is 1 0. If the exponent is 2, there are 2 zeros. If the exponent is 3, there are 3 zeros. So here, we have the same base 10, and the exponent is 1999. That means if we write this in decimal form, this would be equal to 1 followed by 1999 zeros, and 5 squared is equal to 25. And multiplying 25 times this number, starting with 1 followed by 1999 zeros, the result would be 25 followed by 1999 zeros. So this number has a very long numerals. And remember that what we want to find in this problem is to find the sum of the digits of the decimal form. This is now the decimal form. You have 2, 5, and there are 1999 zeros. So for the sum of the digits, we simply have to add 2 plus 5 because all the rest are zeros. And 2 plus 5 equals 7, and that is the answer to this question. The sum of the digits of the decimal form of the product 2 raised to 1999 times 5 raised to 2001 is 7. And this problem is now solve. Thank you very much, and we hope to see you again in our next video. Bye for now.